In this video, we solve problem 5 of Unit 15. We have a current loop which has an axis that is parallel to the x-axis, and with the radius given here, and that is carrying a current of 10 ampere. And they want us to determine the magnetic field produced by the loop in several points along the x-axis. So in its center, at 1 millimeter away from the center, at 1 meter, and very, very far away. So for that, we have to remember what is the magnetic field created by a current loop. So a current loop creates a magnetic field that is given by mu sub 0 times the current that is carrying times the square of its radius divided by 2 times square of radius plus the distance at the x-axis, and this to the 3/2. So we just have to know that mu sub 0 is 4 pi times 10 to the minus 7 Tesla per meter divided by ampere. We also want to know that the current intensity is 10 ampere. The radius is 2 pi to the minus 1/2 in meters. So the rest we just need to know that for x equals 0 meters, then if we substitute, we get that in the x in this point, the magnetic field, the modulus is going to be 1.6 times 10 to the minus 5 Tesla. For the direction, we know that if the loop is carrying a current as the one in the figure, to know the direction of the magnetic field in its axis, we just have to use our hand covering the loop with our 4 fingers, so the thumb points toward the magnetic field. So in this case, the magnetic field has this direction, okay? For x equal 1/10 to the minus 3 meters, then the magnetic field is 1.6 times 10 to the minus 5 Tesla. If very similar, if x is equal to 1 meter, then the magnetic field is 8.0 times 10 to the minus 7 Tesla. And if we go to infinite, then magnetic field tends to 0. Okay, because this part here is it tends to infinite, so B tends to 0.